All right, looks like I'll be repeating myself a little bit there. I'm sorry about that. I have been having some oddities with the audio, and it's how the mute button works on this. Um, Mainly when I was recording stuff, and I was recording stuff for other classes. When I'm doing the live, that's the first time that my mute buttons got all tripped up here. Sorry about that. Woohoo! Yay! Thank you, Tina. Um, all right, so what I want to do is I got some questions. Oh, well, first administratively. Sorry, I have to kind of repeat everything I went through in my list here. Um, the the exam itself is now posted on Pearson. Um, it, I've let you take 3 attempts at it because I think the format's a little odd. Um, it's up online and it's due not this coming Sunday but next Sunday at midnight. And so the word problem exam is there. I'll continue talking about algebraic equations in the lectures, and I'm going to be wrapping up um, the algebra stuff towards the end of the semester. Um, so we'll have one more exam, probably due uh, towards the beginning of May, on the material that we've covered through basically April. And then there's the final exam, which I'll put up online. That's that. Please continue to email me any questions that you may have. If you need anything, just email me, and I can do. I'm running about 2 days behind on email right now. So, for example, I'm asking a question from one of your classmates, Ryan, here. We're going to look at 2 problems he had asked about from the worksheet quiz. And so I'm going to go over them when we start, just like the last class I went over a couple questions that other people asked. I am playing catch up on email, and I hope to get back within my 24-hour notice timeline. We'll see how it goes. It seems I'm getting flooded with a lot of people just now starting to pay attention to the material this week, as the school officially opened this week. So we'll see how that goes. Okay, so that's the exams online. I'm going to be going over things from email today. Um, and, sorry, for Janine, who came in a little bit late, and other people here, I started this whole thing with the audio off. So I'm repeating myself, but to the point where you can actually hear it. And if you've ever had to go through a list of things that you had said and repeating it, I don't want to make sure I'm missing anything. So that's what all the ums and ahs are, as I mentally think what I wanted to cover. Um, no, I apologize for the doodle. I have been finding just putting up the say hello and chat. The audio will start at 10:30 bores me, so I'm probably going to doodle. And about the only doodle I do really well is weird Robert Smith looking punks from the 80s. The fact that the chalk thing in here isn't very neon puts me in like a late 80s feel, right? Um, for those in the know, it's very head on the door. That said, I'm going to get started looking at these problems that were emailed in. And there's 2 of them. So I'm going to start with this one here. Let me see if I have it. Yeah, here we go. All right, and so this is in the worksheet in the class. And it says a car salesman receives bonus points for selling certain types of cars, but can also be penalized for missing the monthly quota of total car sales. And so we get a table of what the point system is. And what we're going to do is we're going to use this table to calculate the car salesman's points. So during the month, the salesman sells 6 subcompacts, 11 full-size cars, 3 luxury cars, but he misses his quota by 20%. So we're going to turn that into an algebraic expression. What I'm going to do is I'm going to make a variable for the number of cars. And so I'm going to use S, F, and L. So we'll come here, let's scroll past my, there we go. So S is worth 50 points. 50 points. F is worth, how many points did it say up on the chart there? 100 points. L, the luxury car, was worth 125. So that's how many points each car was. So the subcompact was worth 50, the full size was worth 100, and the luxury car, I'll make it more like an L than a 1, is worth 125. So I could make an expression where my total number of points is 50 times S plus 100 times F plus 125 times L. So I let each thing in the column have a variable. And then he loses points, penalty points, for how far under his quota he is. And so he's 20% under quota. So I will put him, I'll just put quota here. And so if you're 10% under quota, if you're 20% under quota, and what's the other one? 10, 20, and 10, 20, and 30. So 10, 20, and 30. If you make quota, you don't lose any points, but if you miss quota, it's 300, 450, and 600. 300, 450, and 600. 300, 450, and 600. Notice all of the things here are additive, and all of the things here subtract. So I'll switch back here really quick, and we notice that he sold 6 subcompacts, 11 full size, 3 luxury, but misses the quota. So S equals 6, F equals 11, and L equals 3, but missed by 20%. So I will now take these variables and drop them in to where I put them into the expression. So S is 6, that's going to be 50 times 6, plus 100 times, well, F is 11, so I'll put 11 in there, plus 125 times 3. But he missed the quota by 20%, so he's going to lose 450 points. And at this point, I'm going to let my calculator do my work. So I'm going to type 50 times 6 minus, or whoops, not minus, plus, get my signs right, 100 times 11 plus 125 times 3 minus 450. And my calculator spits out that he got 1,325 points. And so this type of chart works really well if we can think of the columns being different variables. And when we find out the values in the variables, we sub them in. In fact, you could make an equation or a formula, as we've been talking about now. We can make a formula where, hey, your points are equal to 50 times S plus 100 times F plus 125 times L minus Q. And you could walk that formula around, and whenever you found out the different sales and where you were with the quota, you could plug it in and get the total number of points. And I think this illustrates how variables are nice for helping us solve things because they give us placeholders for these values. All right, let me switch screens here. This screen came through a little blurry, so I'm going to do many apologies right off the bat for this. This is blurry, but I can translate it just enough here that we can go. So this is, again, it's problem 47, 11.347. It's the 21st problem in the worksheet. So it says the graph shows the number in millions of dollars that a large company makes for 4 consecutive quarters. What was the overall net per quarter? So there's some wording here. Let me see if I can actually find this problem and pull it up. Bear with me here. I will find a wording on it. The numbers might be different. That was the problem that I was worried about. But give me 1 second to go into my browser. Now, while I'm in the browser and I pull it up on the screen, I will not see the chat as readily as I normally do. So I'm still here finding this for you. Still looking. Yeah. If this were in the classroom, I would be shuffling the page in the book to get to the right one. But I'm almost there. So let's see here. I'll go into the practice exam. Let's see if I can list the questions. And let's see, 21. Yeah, I have it there, but it's not pulling up here. Let me, there, I got it here. Scrolling. Okay, so I'm trying to get to a particular question. I guess I'll have to do it this way. Yep. Almost there. Takes it a while to render the problems. Got a little bar saying 78%, and it's opening all these different windows that I can't open up for you yet. But let's come down here. And of course you can hear the dog having a treat in the back. Well, I lost it it is not printing it out on my printout, so I will use this graphic here. Oh, don't apologize, Ryan. It's good. I can get past it. It's just it's not having me, letting me upload a new version which I can see. So what we're going to do is I'm going to redraw this graph. And from that graph, we'll look at what we need to do here. So there's 4 quarters, and they make money or lose money in the millions. So I'm going to put this off to the side. I hope you're seeing my really bad drawing. Yep, all right, my really bad drawing is coming through. And I'm just going to, the numbers I'm having a hard time seeing here, but I'm just going to put them, I'm going to put my best guess because I know how to do the problem versus what the exact answers are. And so we're going to look at how to do the problem. And so this looks like it's 1.2, and that's the number I'm going to use. This looks like it's a negative 4.3. That's the number I'm going to use. This looks like it's a positive 2.8. And this other one looks like it's a 0.4. And if it isn't, that'll be close enough for how we do the problem. And so the question it's asking is, what was the earnings per quarter? And so there's a per in there, earnings per quarter. And it wants the average earnings per quarter. Well, pers are division. So to get an average something, I need to add everything up and then divide. Well, how many quarters are there? There's 4. So let me come back to my other screen here. Now again, my numbers might be a little off or different than other people's numbers. I'm really looking at the technique. And these are in millions. My screen is not open. There we go. So I'm going to add up the total revenue. So I'm going to call it revenue. And so that's 1.2 million minus 4.3 plus 2.8 plus 0.4. Again, my calculator is really, really nice on this for me. So I get 1.2 minus 4.3 plus 2.8 plus 0.4 is 0.1 million. All right, well, 0.1 million, and I think this might be the tricky part, means that's 100,000. But my earnings per quarter is earnings per quarter. Well, I have my earnings in dollars in 4 quarters, and in this case it's $25,000 per quarter. And it's that per quarter bit that comes at the end. Now again, my numbers might be different than what was on that graphic. I had a hard time seeing it, and if any of these decimal places were off, the number would be a little bit larger or smaller. But that's the technique that we're looking for there. And the key is the per quarter. We have to take an average over the 4 coming across. All right. Please keep sending email in. My goal is to record little videos for everyone and send them out on the particular questions. If there's anything you need, just email me. And what I'm going to do right now is I'm going to look at some things from the workbooks that we would have been doing in class. Let me get this up on the screen here. And we're going to be looking at evaluating algebraic expressions and formulae. I really want to look at the idea of formula and formulae and expressions so that we can build equations, because equations are what we're going to be working with from here on out. How we have equations to represent unknown things. And so we're going to look at evaluation, and from evaluation, we're going to look at substituting into formulae. And we talked about this idea of getting terms to come together, and evaluation. And if you noticed, if we go back to the car salesman problem, we could say once I knew what the car salesman was selling, I evaluated the expression I made. I put numbers in place of the variables. And so when we use the term evaluate, we have something that has unknown things, and we put numbers we have into the unknown things. When we have equations, we have unknown things that we either solve for, where we get absolute answer for the unknown thing. And one of the techniques that comes out of this that I haven't talked about much was tabling. And so I'm going to look at a table. So I can have an expression. And the expression I'm going to have here is going to be negative 3y squared. So I have negative 3y squared. Well, this talks about a whole bunch of possible answers, depending on what I put in for y. So what we can do is we can make a table. And what I will do with my table is I will look at what happens to all the answers I have. I will look for a pattern in the answers if I put in particular values of y. And so now your book tends to go 0, 1, 2, negative 1, negative 2. I tend to go the other way. I write it like it's on a number line. So I tend to put my 0 in the middle. I'll put my negative 1 here and my positive 1 here. My negative 2 here and my negative 2 here. And what the table is going to do for us is it's going to show us what the answers look like if we were to put these numbers in. So for this first column here, I will change colors as I go through. So for my first column here, I'll go in pink. I'm going to put negative 2 in everywhere I see y. So negative 3. Now I'm going to keep parentheses here. So negative 2 squared. And my calculator is going to do a nice thing for me. Negative 2 squared is going to be positive 4. And positive 4 times negative 3 is negative 12. But if we enter this in the calculator, remembering it's not a subtraction sign, it's the negative sign down in the bottom right of the calculator, and we keep our parentheses for us, and I type it in just as shown, it will spit out the negative 12 for me. And so the answer here is negative 12. Right? And I'm going to keep working across the table. I'm going to put in negative 1. I'm going to put it into this expression wherever I see y. So negative 3, negative 1 squared. Negative 1 squared is positive 1, and positive 1 times negative 3 is negative 3. All right. 0. 0 is nice when you have multiplications. So if I put negative 3, put 0 squared, well, 0 squared is 0, and 0 times anything is 0. So I get that. I'm going to come over here, and I'm going to use yellow again. But I'm going to write down here. And what I want to do is I want to take 1 and put it in wherever I see y. So negative 3 times 1 squared. Well, 1 squared is 1, and 1 times negative 3 is negative 3. Now, I'm going to fix, notice the little weird thing I did here. I'll fix this here. I need to go erase that, fix my number here. It should be a positive too. I wrote the negative in there because I was so excited about getting my number line fixed. So I will do that in red. Well, negative 3 times 2 squared. Well, 2 squared is positive 4, and positive 4 times negative 3 is negative 12. The table can help us see a pattern that actually explains some things about our expression. One of the things I told you to keep an eye out for, and I'm always going to emphasize this, I will repeat myself a lot. This is not, me going, oh, you haven't known this yet or whatnot. It's by emphasizing these certain patterns that come out that I hope we can see them a little bit better. Any number I square, right? When I squared negative 2, negative times negative is a positive. When I square positive 2, a positive times a positive is a positive. Even powers will always give me a positive number. So whatever I put into y, is this part of it, the y squared part, will be positive. And a positive times a negative is negative. And so notice all my answers, except for lowly 0 here, were negatives. So it's part of the pattern we're seeing here. Also notice that the opposites, the 2 and the negative 2, give the same results. When 1 and negative 1 go through this expression, I get a negative 3 and a negative 3. And this is a pattern we'll see for anything that's squared. And we will explore this pattern. But a table helps us start seeing the patterns that we have for different expressions. So let's look at a table for another expression. I'm going to scroll this up. And I'm going to look at 2b squared plus b. I think I will do my expression in blue. 2, I'll give some room here. 2b squared plus b is the expression. And so I want to look at some different values of b. And I'm going to do the same thing. I'm going to put 0 in the middle, so let me get my table together here. And I think I'll write so I'll put 0 in the middle. I'll put 1 there. And I'll put 2 here. I'll put negative 1 here. And I'll put negative 2 here. Now again, I like making my tables look like a number line. I like my 0 in the middle, and then in my positive numbers to the right and my negative numbers to the left. This just lines things up with a number line for me. So my job now is to put these values in for b. So I'm going to start with negative 2, and I'm just going to work my way from left to right. So wherever I see b, I'm going to put in negative 2. And I'm going to use parentheses so I can keep track of my signs. And so negative 2 squared is positive 4, and plus a negative is the same as subtracting, and I get 6. I'm going to do the same thing now with negative 1. I'm going to drop negative 1 in wherever I see b, remembering to keep my parentheses. Sorry, I put a little line between my work here. So negative 1 squared plus negative 1. And negative squared is positive, and that's the same as a subtraction. And so I get 1. Alright, we'll repeat the same thing for 0. So wherever I see B, I put in 0. And 0 squared is 0. And so we get 0 back. And so by dropping these in, this repeats itself. Well, let's look at what happens, though, when I get to the positive side of my numbers. Because this plus b over here means that I'm not going to get 1 coming back. I'm going to get a different number. So let's look at that. I'm going to scroll down just a little bit here. And so I'm putting 1 into... Oops. I'm putting 1 into 2b squared plus b. So I'll come down here. Wherever I see b, I put in 1. 1 squared is 1, so I get 2 times 1 plus 1. And 2 plus 1 is 3. So I'll come back up to my table, and I'll put in 3. And then for the last one here, I'm going to put 2 into 2b squared plus b. So wherever I see b, I put in a 2. I will keep my parentheses. 2 squared is 4. And I get 10. And so there is a pattern to here where definitely our numbers are going down, then they start going back up. The shifting of this extra b term, though, meant that it didn't have the same symmetry around 0. There wasn't this equal stuff on either side. And tables are going to be our tool that are going to let us see these patterns. For right now, making the table is our goal, right? Trying to grab all the pattern out of it. We're going to invent some other tools to help us see deeper pattern. But using the table to look at how this expression can manifest itself over different values. A good value to always use are 0s and 1s. Because they make easy calculations, and so -1 is also a nice thing to see. For a lot of the tables in the book, they're going to ask you to go from -2 to 2. Now the book lists the tables. They'll say 0, 1, 2, -1, 2. And I'm going to repeat, I like, and I think it will help us, especially when we turn these into graphs, to set our 0 in the middle, because our number line has 0 in the middle. All right, and so tables are a tool that we work with a lot. Okay, let me close this out here, come over here. We're going to talk about equations a bit more. We had talked about equations before, and equations are expressions. And there's 2 expressions. So an equation has 2 algebraic expressions connected by an equal sign. And for example, I can have y minus 6 equals 9. This is an algebraic expression. It has a variable and constants. This is an algebraic expression that has just a constant. Our job, firstly, is to evaluate these as being either true or false. Equations evaluate to being either true or false. So I could make the equation 9 equals 6 plus 3. And I'll do this addition over here. I get 9 equals 9. It's true. I could evaluate the equation 9 equals 6 minus 3. I do this side over here, and it's false. Equations are something we evaluate. But when we have variables in them, we will make the assumption that it's always true. And that's okay. If we make the assumption it's always true, all those properties of real numbers we've used before still hold, and it's going to tell us if it's false or not. And most of the time what will end up happening is we'll be able to figure out what our unknown thing is. So an equation has two algebraic expressions connected by an equal sign. We'll call the left side the left-hand side. And yes, it's mathematical theorems write left-hand side, and they'll write it as LHS. And we'll call the right-hand side the right-hand side, and we'll abbreviate that as RHS. So our job, the goal that we're going to go for equations is, this is an unknown thing. All right, if we go back to the translation of algebra, the reconciling of disparagant parts, and Alshan, the unknown thing, well, here we want to find what this unknown thing is. And so we have two parts. We have a left-hand side and a right-hand side. If we want to reconcile it, if we want to get it into a format that will have meaning for the unknown thing, well, we want to get the unknown parts on one side and the known parts on the other. And all of algebra, up to the higher levels, involves getting your unknowns to one side and your knowns to another. Then you have techniques for sorting out all the different unknowns. In this case, and I'm going to take this one here and I'm going to write it on a new page. So I'm going to scroll up here. We would love to have y on its own. But this 6 is in the way. In fact, specifically a negative 6. So I have to do the opposite. If this is subtracting, I want to add. But whatever value of stuff is here, that's the value of stuff over here. So if I'm adding 6 to this side, if these values are to stay true, I have to add 6 to that side. And you have heard me say, jump up and down, whatever you do, to one side, you do to the other. Now the book's going to break it down. It's going to focus on addition and subtraction and multiplication and division. And eventually we'll look at what happens with powers. But it focuses on each one of these things as a different thing. Well, notice this equation had a subtraction in it. To undo it, I did its opposite. And what we'll find is that we're peeling away things in the reverse of our order of operations. When we do a series of expressions, we start at the top, right? And I guess I'll call these exponents, not powers. And then we have our parentheses. So we do things in parentheses. We do the exponents first, we do the multiplications and divisions, and we do the additions and subtractions. If I'm trying to solve, I work from the bottom up. I undo the additions and subtractions. I undo the multiplications and divisions. I undo the exponents. And that will peel away layers, leaving me with the variable. And so the work we're going to be doing here is all the different things we can do in this order of operations to peel away the layers. So I'm going to look at a couple different equations and how we can solve them out. So, and let's evaluate one. And I'll show you an evaluation with a solution. So this is going to combine an evaluation and a solution. Showed you what one looked like when it was true. I'm going to show you what one looks like that we don't know if it's true or not, and how solving will put it together. So let me get 2x minus 4 equals 6 times the quantity x plus 2. 6 times the quantity x plus 2. So I have two disparagant parts here, and I want to isolate x. I want to get all of the x's onto one side, and I want to evaluate this so that I can see what is happening. Now, I have some additions, and I have some parentheses. What I want to end up doing is, this is my focus point. I need to get x on its own. So in this case, I'm going to distribute first. So I'm not going to touch the left-hand side. I'll leave it as is. And I'll distribute this 6 into the parentheses using my distribution property. So I get 6x plus 12. Now, I'm still going to focus on this. I would like all of my x's on one side. Sorry, I was just thinking like all my x's live in Texas, right? You get them in one side. And that was the heavy pause there. And what I'm going to do is I'm going to get my x's over to the right-hand side, because this is the larger x. I tend to pull all my x's towards the larger x. I could pull the other way, but I'm going to find that it's I won't have to worry about my signs as much if I always move towards the larger x. And signs are the problem here. So if I want to get rid of this x, I subtract it. But whatever I do to one side, I do to the other. And so these two things, 2x minus 2x, well, they'll cancel out, leaving me with negative 4 over here. 6x minus 2x is 4x plus 12. Well, I'm close. I've got my x on one side, but my numbers are not. Again, this is what I'm focusing on. This is what I want to get down to, is just the lowly x. And so 12 is in my way. So I want to subtract 12. I'll repeat again though, whatever I do to one side, I do to the other. And notice I've lost all my additions and subtractions. I now have something times x equals something else. I'm going to pull this stuff up here. Well, this is a multiplication. So to undo a multiplication, I do a division. The 4 over the 4 will become a 1. But whatever I do to one side, I do to the other. And the only value of x, this thing we call a solution, the only value of x is the only thing that if I plug in to what I started with, the 2x minus 4 equals 6x plus 2. This is the only number that makes this true. Any other number I put in there, this would be false. And so this idea of solution is what keeps this true, what keeps the equality true. Now, there are many different types of equations we can have. We could have an equation where we have some number, this is going to be a number, not a variable, times our variable plus some number equals another number. Now, I'm going back, remember when I said A, B, and C, these represent a particular number. While x, y, and z are variables, they can vary. And this is something that ends up happening, is we have to talk about how things look. And this looks like some number times x plus another number equals another number. And so I'll give you an example here. 3x plus 1 equals 7. And in this case, A was 3, B was 1, and C was 7. They're placeholders for talking about these numbers. Well, the x is still a variable. This form is called a linear equation. And we're going to study linear equations in detail. They can have very wide-ranging uses. And so we're going to practice over the next lecture, and all the way in through when we're graphing, and we'll see where the name linear comes from within the graphs. And we're going to look at this form of ax plus b equals c. All right. we're kind of at where I would normally be giving out the worksheet, and we'd be looking at the different types of things to do in class. So what I'm going to do is I'm going to post the PDFs of the worksheets up on Blackboard, but I'm going to make a quiz version of it. I'm going to put that online. Again, our due dates are in next week sometime, because this is when I'm recording the videos, not when they're due. And I have you guys in here for questions. There wasn't many questions today. If you need anything, please let me know. I'm also putting up the PowerPoint lectures, and I'm trying to get them all there. I'm going to, that the book has. I tend to use those when I build my own notes, but I do some things in different orders, and if you've noticed, I've commented, oh, the book does a table this way or that way. But I'm going to also put those up in Blackboard as I'm doing them, since we're into nothing but exclusively new material at this point. So I will be putting all that stuff up on Blackboard. Does anyone need anything right now? Right. This would be in the time of class. I'd be handing out papers, and we'd be working on this. And the thing that will be coming out of this one will be looking at linear equations and looking at if equations are true or false. And that's what we'd be practicing at this point. All right, I guess for lack of better things, I'll scroll up to my Robert Smith head. And say, hey, guys, be safe and be well. And if you have any questions, holler.